Okay, in this video, we're going to talk about electrical plant design. And the first topic we'll discuss will be the different typical symbols that are used on electrical plans. We'll just go over the basic ones, the main basic ones that I typically use, as well as most other engineers. Then we'll be going through the voltage, phase, and hertz information that's used in the U.S. And the voltage typically is like about 120 or 208. The phase just represents, how many of those hot, energized phases are going to a particular panel or a circuit. And the hertz is the frequency of that alternating current voltage. Then we'll discuss electrical panel schedules and explain the various parts of it. And the electric panel schedule is basically the electric panel where you list the different circuits, and we'll be going over those the parts of that panel schedule in detail later in this video. We'll also talk about the standard overcurrent devices, which include circuit breakers and fuses. These are two different types of overcurrent devices that can be used, and they look a little bit different from each other. Then we'll talk about circuiting, or providing a power to motor loads, as well as all the different components such as the disconnect, overload, and controllers, etc. that is required for motor loads. Then we'll talk about general rules for loading circuits. So there's a certain percentage that you have to load a circuit to, because if you load it too much, there's a potential that it can trip the breaker or the fuse. And if you load it too much, you might not have any room for future expansion onto that circuit for additional loads. Then we'll talk about the various power formulas that are for different voltages. So for a single phase, the power formula will be different from a three-phase circuit. We'll then talk about feeder taps, what it is and how to size them. Then we'll go into sizing the conductors, which are the wires, and conduits, which are it could be a metal pipe, it could be a flexible kind of cable where it contains the conductors within. So that's what a conduit is. Then we'll discuss some general rules to follow, some good principles to follow when filling out the panel schedule. Then we'll go into designing the electrical power and lighting plan for an example restaurant, where we will apply the things that we have learned in this presentation. So here are some of the basic common electrical symbols that you can typically see and use when designing these electrical plans. So first is the new electrical panel board. So it's just a box, typical size approximately 20 inches or so by 6 inches. And these are what the electrical panel boards typically look like. So on this one, this is a installed one with the circuit breakers that you see here in black and the main circuit breaker up here. And the inside of the panel board, when the circuit breakers are removed, as well as the cover, it looks like this right here. And the copper is the energized portion, so the wires would come here, there's screws, and then you would basically connect the hot legs. So this could be phase A, next phase you could consider that phase B, and then you would basically energize these copper buses inside the electrical panel. For existing, we use the color yellow, so the existing panel board would be this symbol here. And yellow, using our plot styles, would print out lighter, and that's the reason why we use yellow for existing panel boards. Different companies might have different colors that they use for existing, or they might show the existing as a dashed line or different type of line type such as that. This is the common symbol for a duplex receptacle and a simplex receptacle. So the duplex receptacle is basically something like this, where you see two outlets, which is why it's called a duplex. And a simplex is this right here, since it's just one outlet. Okay, so this here would be considered a GFI receptacle. These are the testing buttons for the GFI. Okay, so those GFIs are indicated like this. Same as a receptacle symbol with the wording GFI right next to it. And if we have a waterproof GFI, we also include the /WP to indicate that it's a waterproof, or another word is it's really called weatherproof. It's not waterproof. Waterproof means it could be kind of submerged in water. In this case, it's just weatherproof, so it could withstand rain and snow, things like that. And this is a duplex, basically with a weatherproof enclosure and GFI. If you look here, there's also the test buttons, which indicate it's a GFI receptacle. You also have a symbol for a junction box. It's just a circle with a J inside the circle, and this is what a junction box is. It's just a place where these screws right here would be removed. So this plate here would get removed. Inside, the wires would be exposed once it's removed, the cover plate. And here's where you make all the splices, or you can pull wiring. So if you have a very long length of wires, you can open this up, pull the wire into this, and then start from this point to the next point and pull that wiring. Rather than pulling it the entire distance, which can be difficult. Again, also these junction boxes can be used to splice the wires. Splicing just means that you have one end of a wire, and then you take another end of a wire, and then you basically connect these two together using some sort of splice, which can be screwed on, or there are different ways. You can maybe crimp it on, which means you basically squeeze it together. And the splice basically connects the two segments of conductors. We also have a motor load, which is a non-fused. So this represents the motor, and this represents the disconnect. As you can see here, this is a disconnect symbol, and the disconnect symbol here is indicated as a non-fused disconnect switch, a NEMA 1 type enclosure for non-motor load. NEMA 1 type enclosure just means it has a certain rating for indoors, outdoors. So a different NEMA type, it can be rated for outdoors, rain, snow. I believe this NEMA 1 is just for indoors. So that's what this NEMA rating means, or this NEMA type means. Now, if you have this non-fused disconnect switch on a motor, this is the symbol that you use for the motor loads. This symbol right here represents how many basically conductors are going to that particular equipment. So this has one arrow, which means one hot leg is going to that circuit. If you have two, it means two hot legs are going to that circuit. Sometimes you could have a three-phase, which means that you'll see a third arrow, which just represents that it's a three-phase circuit. So it's a conduit and wire home run. Half arrows indicate number of poles occupied in panel board. So home run just means that it's basically going straight to, or basically coming straight from the panel, the wiring to that equipment. And you'll see how these will be used once we go over a plan. So the disconnects basically look like this, and you see the handle is right here. So if you want to disconnect it and turn it on, you would basically flip the handle up or down to disconnect and re-engage the circuit. And inside of this will be your fuses. So you have more of these receptacles listed here, and it's various different types of receptacles. So we'll start from the top. Wall-mounted separate circuit duplex receptacle, 15 or 20 amp, 120 volts, single phase, grounding type with cover plate. So when you have this filled in middle section, it just means that it's a dedicated, or in other words, a separate circuit. So you have nothing else on that circuit that is serving that receptacle. You can also have this type of text here. It says N14-30. So that is a wall-mounted separate circuit receptacle, 120/208 NEMA 14-30, grounding type with cover plate. So the NEMA 14-30 is a specific type of receptacle, which I'm showing right here. It has the 120. So one of these are 120s. Another one might be a neutral. Again, I'm not sure if this exact location is the neutral, but one of these four is the neutral, and the other one is also 120 volt. Again, the location of these might be different, but out of all of these, two of them are hot legs. One is a neutral, so you make a 120 with one of these hot legs and the neutral, and then with the two hot legs, you make a 208 single phase. That's why it's written out like this, where it says 120/208, since you could get both of those voltages from this receptacle. Plus, you have a ground, so that's why it's a grounding type. So a NEMA 1430 type is typically used on electric clothes dryers. So whenever you have a residential electric clothes dryer or any type of electric clothes dryer, usually it's going to be a NEMA 14-30 receptacle. You can also have a symbol like this where half of it is hatched and the rest is not, and that is a wall-mounted split wire receptacle with one outlet switched and the other always energized. So that means that out of these two, let's say these two duplexes, one is a switched one and one is powered. So the switch is basically, it just means that it's connected to a wall switch somewhere on the wall. This is the switch symbol. And this is basically for floor lamps. So if people want to plug in a floor lamp into a receptacle, they would maybe want that to be switched. So that's why you have receptacles such as this one. You can also have a floor-mounted quad receptacle. The symbol looks like this right here. And an example would be this right here. This would be an example of a floor-mounted quad receptacle because you have four of them in that floor receptacle. You can also have a symbol such as this, which is a ceiling-mounted duplex receptacle. And here is an example of a ceiling-mounted type. In this case, it's a retractable type, so it basically spins on this right here. So somebody could grab it, pull it down, and then plug in whatever they need to. And then once they're done, they could just kind of pull on it, and it should automatically wind back upward. These are typical for like warehouses, workshops, wood workshops, things like that. You can also have a quad, which we went over right here. This is a type of quad. Or you can have something like this, but just another one next to it. That would represent a quad receptacle. You can also have a wall-mounted dedicated simplex receptacle. And the simplex, we looked at it over here. This would be a simplex type receptacle. Now, we could indicate the disconnect such as this right here without any numbers inside of it, or we could represent it with two numbers, A and B. So the A indicates the rating of the disconnect switch, and B indicates the fuse size of the disconnect. So let's say we have a disconnect that is 100 amp rated. We will put 100 here. And inside, we can have a fuse that is less than 100. We can have a 50 amp fuse, or let's say a 60 amp fuse or whatever. that number of the fuse or the rating of the fuse would go on this bottom portion. And you can do that because as long as the fuse is no higher than the rating or the amps that the disconnect is basically rated for, it is fine. So the fuse should be at most the rating of the actual disconnect. But it can also be less than the rating of the disconnect. You can also have a 3-pole circuit breaker. That's what this symbol represents. And it doesn't have to be a 3-pole. It could just be a single-pole circuit breaker. And this is the symbol that we typically use. This is the symbol for a electric meter, just a circle with an M inside of it. And this is our symbol for a combination smoke CO alarm. And the CO smoke alarm is different from like a fire alarm device because these are powered by 120 volt single phase, whereas a smoke detector, not an alarm, or a CO detector typically represents a device that is connected to the fire alarm system, which is powered by 120 volt single phase, but the actual detectors, it's typically powered by something less than 120 volt power. Okay, these are some more electrical symbols, the common ones that we use. So these represents switches. Looks like a dollar sign. And we also have these notations here, which specifies a different type of switch. So an SS would be in this case, we labeled it this model number by Watt Stopper. It's the manufacturer of this type of switch, or approved equal. Okay, so we have a DS. The D stands for dimmer switch. So we represent it with this text here. And, we specified this model number or approved equal. And Watt Stopper again is the manufacturer. Same with the OS. It stands for an occupancy sensor wall switch, such as this or approved equal. And MO is a manual override for the Watt Stopper system. And override just means that, if you have some sort of time clock that shuts off the lights after a particular hour to another like morning time, let's say, for example. And if somebody needs to go in there and turn the lights on, they would basically use this manual override switch to turn the lights back on during a scheduled time that the lights would be off. So that, let's say, for example, a janitor can clean an office or something like that. You can also have a DA, which is a data line switch. So there's various different types of switches that you can use, and depending on the particular switch that you want to use for your project, you could denote it with a couple letters, and then in the symbol list, you can describe what that switch represents. And again, these are typical switches you see here. You can see this is a plain on-off switch. This would be a dimmer switch where this would slide up and down to dim the lights. This is an occupancy sensor switch. You can see this right here senses the occupants, and if it senses it, it can automatically turn on the light. And when it doesn't sense an occupant for a certain preset time, the lights would shut off. Here again is another dimmer type of switch. You can see the up and down arrows here, which would dim the lights. You can have an occupancy sensor, which is this. So you can either have the sensor on a wall switch, or you can have them on a wall, or even on the ceiling. So this particular type right here would be a ceiling type, but they do make wall type occupancy sensors as well. Okay, and if you want to use a particular type of occupancy sensor, again, you can denote it with a letter and then provide the description as to what it is here in the symbol list. You can also have daylight sensors, and the daylight sensor basically would sense the light in an area where you do get daylight in, so next to a window or a skylight. and depending on a certain light level, that's when the lights would turn on. So if it's very bright outside, the lights would automatically turn off based on the daylight sensor, and only when it reaches below a certain light level will the lights turn on if there is occupancy in the room. So if there is no occupants in the room and it's nighttime, for example, the lights wouldn't automatically turn on. Only if you have those two cases where there is low light level and occupants, then the lights would automatically turn on. You can also have a data telecom symbol here. So let's say that the telecom portion would just be the unhatched portion, and the hatched portion would be the data portion. So if you have telecom and data together, you basically get a triangle that's split between hatched and unhatched portions. You can also have a 220 volts wall dedicated simplex receptacle, which would be denoted just like this, with a standard simplex receptacle symbol with the 220 volt label next to it. And that 220 volt would look like this. Again, the shape of it is different. It's sideways rather than vertical. It would be the NEMA 6-15R. R standing for receptacle, P representing the plug side. So this would be a picture of a NEMA 6-15R. Since it's rated for 250 volts, which is also rated for the 220. All right, so the typical voltage in the US is 120 volts, 277 volt single phase. So these are the three common ones that you will encounter in the US. The single phase is going to be the most common one is the 120 volt single phase, which if you have three of these 120 volt single phases, you get a 208 volt three phase. And if you have two of these 120 volt single phases, you get a 208 volt single phase. So what you see down here, if each one of these was a 120 volts, then this would be considered a 208 volt single phase. Now if you had one more 120 volts in this panel, so you have one more copper bus down here, that would be a 208 three phase. And similarly, instead of 120 volt single phase, you could get a 265 volt single phase, and that would be the equivalent of a 460 volt three phase if you had three of those 265 volt single phases in the panel. Same thing with 277 volt single phase. If you have three of those phases, you get a equivalent 480 volt three phase panel. So what you see on the right in green is a typical panel schedule that I use. Different companies have a different format for their panel schedule, but the panel schedule that I use looks like what you see here on the right. And panels should be selected, first of all, based on the voltage and the amp rating and the phase, pole number, MLO, whether it's non-auto or a main circuit breaker switch, recessed, surface mounted, feed through, and some other properties too. So I'm going to go through each of these. All right, so first, when we talk about the voltage is listed right here up on top of the panel schedule. So we have to first indicate the proper voltage that the panel schedule needs to be in. Now the amp rating is listed right under that. It's the bus rating or the copper bus rating of the panel, and the amperage is listed right here. So we have to make sure that the bus rating can handle the total amps of that panel. So whatever you load the panel to, whatever circuits you put on it, whatever equipment is on this panel, you have to make sure that the total wattage, which is listed down here, or the total amps that that total watts converts to, can be handled by the amperage of the panel. So the bus rating has to be higher than the total amps that is proposed to be drawn basically from that panel. The phase is important. You have to make sure if the phase, which is indicated right here, is the proper phase that's labeled. So if it's a single phase, you put 1 pH, or if it's 3-phase, you'll write 3 pH. And slash, you see the 3W, that just represents 3 wire. So hot legs and neutrals are all considered within that wire count. So with a single phase, you have a 3 wire because you have 2 hot legs and 1 neutral. So you have 3 wires. If it was a 3-phase, it would be a 4 wire because you have 3 hot legs plus 1 neutral. So that information would be listed right here. Pole number, or in other words, space number, is listed right here. So you have the poles, okay, because you have 2 sides of the panel. So if you look back here, you have 2 sides, one side here and one side here. You have the poles. So on the left side, it would be odd numbers if you look down here. And on the right side, it's even numbers right here. So 2, 4, 6, all the way to 24, because in this panel, we have a 24 pole or 24 spaces in the panel. And that will be listed here as well, right? 24 pole. And you indicate if it's new or existing right here. Now, you can have different you can have different components to this panel schedule. It could be a main lug only, a non-auto, or main circuit breaker. So those 3 will be listed right here under this section where it says main circuit breaker. It doesn't have to be a circuit breaker, but this is just the way we labeled this area of the panel schedule. And you would indicate whether it's one of those 3. So MLO, a non-auto, or a main circuit breaker. So the MLO stands for main lugs only. So if you look down here in this picture, this would indicate main lugs only. So you see there's just lugs here, the 3 lugs right here, 1, 2, 3. The wire would slide in, and then you would basically screw it down so it makes a solid connection to the copper bus of the panel. So that, what you see here, is main lugs only. If you have a main circuit breaker, it looks something like this. So this is the main that basically then feeds the entire panel. So when this main circuit breaker opens up, it shuts off the power to the entire panel. And if you just have a non-auto switch, it would be similar to this, but it wouldn't be a automatic circuit breaker that would trip and open up if it exceeds the breaker rating. So if it was a 100 amp breaker and it goes to, let's say, 150 amps, the circuit breaker would automatically open. But for a non-auto switch, it wouldn't automatically open up. It would just be a manual on-off switch. You can also have recessed or surface mounted. Okay, so that would be listed right here. The mounting type, whether the panel is a recessed type or if it is a surface mounted type. So these are the pictures. A recessed panel would look like this. It's basically flush to the wall. And a surface mount would basically be on the wall and the panel would stick out like in this picture right here from the wall that is surface mounted on. All right, so the electric circuit breaker and fuses, they have standard sizes. You can't just pick any size that you want. They come in standard sizes listed here. So the lowest one would be a 15 amp, and then it would go up in increments of 5 up to about 50, yeah, up to 50, and then increments of 10. So this table gives you the standard circuit breaker sizes as well as fuses. And fuses are overcurrent devices, just like circuit breakers, but they look like this over here. And they will basically go into a disconnect such as this. This is a disconnect with the cover opened up, and you could see the fuses are placed inside here. So in this case, this could be, for example, a 208 single phase circuit if 120 volts were going into each of these phases here. Now you can have different type of circuit breakers, a 1-pole, 2 or 3-pole, and these are basically how it looks like. It's connected with a handle that basically is connecting both of the single circuit breakers, and for the 3-pole, it's just one handle that connects 3 separate circuit breakers together. All right, so when we are circuiting electric motor loads, there's a couple of rules that you need to follow. So let's first look at the diagram at the bottom here.